So here's the review for the quiz for you guys. Um, what you're going to do is u sub should be your u substitution 3t to the fifth minus 4. So du equals 15t to the fourth dt. All right. So here, notice that I have t to the fourth. I just don't have 15. So if I put 15 here, I got to put 1 over 15 here. All right. So when I do this, I'm going to have 1 over 15, the integral. All of this right here is my du. And then here, all of this is my u, and I'm going to make it to the 1 half. All right. So when I integrate it, 1/15th, u to add 1 to 1 half, so I get 3 halves. Divide by 3 halves, like that. All right. Don't forget plus c for your indefinite integrals. All right. So here, I'm going to have 2. I can go ahead and replace u. 3 t to the fifth minus 4, use parentheses, raised to 3 halves. All over 15 times 3 is 45. And then again, don't forget plus c. All right, number 2. All right, here u should be 1 minus x squared. So du equals negative 2x. Don't forget that negative because of that minus right there. Now I have x, I just don't have the negative. I have this extra 5. And what we can actually do, I'm going to erase it, and I'm going to move the 5 out here. All right. And then negative 2. But here, if I'm putting a negative 2 here, I need to put a negative 1 half out here. All right. So really, I have this negative 5 has as a constant out here. This is 1 over u to the fourth du, because here's all my du right there. All right. Now, negative 5 halves, I'm going to raise this up. So it should be negative, or u to the negative 4 du. All right, so when I integrate it, negative 5 halves times u to the, be careful, negative 4 plus 1 is negative 3. Divide by negative 3. All right, and then plus c. We can clean up as we go because these negatives right here will change to a positive. It's going to be 5 u to the, so my u is 1 minus x squared, and then out to the negative 3 over 6 plus c. Now, you can choose to keep it like this, or you can bring this down so that the 3 is no longer negative. All right, number 3. Okay, so here, ooh, this one's, hold on one second, I might have to change the, hold on, I gotta see what, I changed it to, hold on, I just rewrote this wrong. So this is cotan of 3x, and then cosecant squared of 3x. Some things I start seeing is I see cotangent, and I know the derivative is cosecant squared. All right, so my u should probably be cotangent of 3x. All right, so when I take the derivative, that is, now, because I'm taking the derivative of c, it's going to be a negative, cosecant squared of 3x, but don't forget chain rule here. The derivative of 3x is 3. I'm just going to put it out here, and then dx. Now I have all of this. What I'm missing is the negative 3. So let me put it here, and I'm going to need a negative 1/3. All right, so when I rewrite this, negative 1/3, this is just e to the u, and all of that right there is my du. Okay, so I've really simplified it. When I integrate it, negative 1/3 e to the u plus c. So this makes negative 1/3 e to the, my u is cotan of 3x. All right, and then plus 3. All right, and if you want to, you can just put this over 3, just make sure it's negative, and so forth. All right, moving on. 3 more. Okay, so number 4 right here. Now you could try to simplify this to see if it simplifies into something, but I see tangent and secant squared. I know the derivative of tangent is secant squared. So if I do u is tangent, all right, and my du of that is secant squared x dx. All right, so here I see the secant squared x dx, so that's du. Okay, I have everything's perfect. I don't need to add anything to it. This is going to be 1 over u to the fourth. All right, so this is make u to the negative 4 du. All right, and then now add 1, so that makes -3, divide by -3 plus c, because it's still indefinite. All right, and so this is going to be tan to the -3x, all right, over -3 plus c. You can change this, so it's -3 over tan cubed x plus c. Also realize this answer can actually change. I mean, you can leave it all like this, but if it's multiple choice, here, 1 over tangent is cotangent. So this is the same thing as -3 cotangent cubed x plus c. All right. All right, number 5. My u is -x squared over 4. Okay, so now you can treat this as -1/4 x squared, might be a little easier for you. So that when you take the derivative, it's -1/4 times 2, whoops, fourth, times 2x, and then it's dx. And then here you see this -1/4 times 2 actually can change to -1/2 x dx. Now I see the x here, dx, but I don't see the -1/2. So -1/2, that means I needed -2. It's the reciprocal on the outside. So -2. Now this one is a definite integral. So I'm going to put u of 0, and I'm going to put u of square root of 3. And I'll come back and find what those new bounds are. All right. Now here, this is e to the u, du. Okay, let's go find those new bounds. U of square root of 3. Okay, so let's think about this for a second. Square root of 3 and then squared over 4. Well, when I square something with the radical, that makes 3/4. So this changes to 3/4. All right, and u of 0, well, this is -0 squared. Oh, and you know what? I didn't put the negative on there, so that's actually -3/4. All right, so -0 squared over 4, that gives me 0, so that's just 0. So when I integrate this, this is -2 EU, but my bounds are 0 to -3/4. All right, so here, -2 e to the -3/4. All right, minus -2 e to the 0. Now, to clean this up, and again, you don't need plus c because this is definite. This minus negative goes to a plus. The other thing is e to the 0 is 2. I mean, is 1, so that's 2 times 1, which is 2. All right, another thing that can happen here is we can bring down the e, and that exponent becomes positive like that. And so that this can be, sorry, the final answer that you see. All right, one last one. Again, this is definite, so you don't need a plus c for it. My u is 3x minus 2. Du equals 3 dx. All right, I don't see the 3. I'm going to need it. All right, so I need 1/3 out here. So when I write this 1/3, all right, I'm going to put u of 5 and u of 7 because I'm about to put u's in, so I have to change my bounds. This is going to be u to the 1/2 because you got the square root and then du. All right, so u of 7, 3 times 7 minus 2, that's 21 minus 2, which is 19. All right, u of, what was that, 5? So 3 times 5 minus 2, that's 15 minus 2, which is 13. Okay, so when I integrate this 1/3 times, this is going to make 3 halves, so divide by 3 halves. All right, and I'm doing it from 13 to 19. Not nice numbers, it's fine. All right, so this makes 2, and I'm going to plug in 19, 3 halves, over 9 minus, now plug in 13, so 2, 13 to the 3 halves, over 9. Usually things work out to where you would actually have, like, if 9 to the 3 halves, you would change it to 3 squared. Same thing if 4 to the 3 halves, you would change it to 2 squared, and then the 2's cancel, and you're doing 2 to the 3rd. But here, there's our final answer. That one's not going to reduce any further.